Great. So as I told you, our company is called the Spime Sense Labs, and our main product is an application enablement platform. We call it Master of Things. So we have been doing that for 11 years now, and through this journey, we have got some rewards and recognition. Some of them are local, some of them are international. Because it's 11 years, we have partnered with a lot of our, we call them friends rather than just partners. We do partner with telecom operators, connectivity providers in general, and device makers, IoT device makers. So you can find us in some international reports today. So you can find us in one of the well-known reports is a report developed by a company called MASH Nation. Some people call it Mac Nation. That's an American-Canadian company. So they categorize, they study the IoT platforms and they categorize them. They put us in this fourth quarter. This is a horizontal platform. It means it's not built for a specific use case. And it is a broad offering. It means it can be deployed on the cloud or private cloud or on premises, depending on the customer requirements. You can also find us in some governmental projects, like famous one in Egypt is Smart Transportation Station, managing central transportation stations. You can also find us with the Ministry of Information and Communication Technology when it comes to innovation and education labs. We have 11 of those IoT education and innovation labs today. And in a couple of months, we'll have lab number 12. These are distributed among different locations in Egypt, usually inside the university premises. These are a lot of devices, IoT devices. Some of them are commercial devices. Some of them are innovation kits with a lot of different wireless technologies, Sigfox, LoRaWAN, Bluetooth Low Energy, Wi-Fi, and so on, with our IoT platform, Master of Things, that collects data from all of these devices in the different premises in these labs, with a curriculum how to develop IoT solutions. Some of the curriculum, parts of the curriculum are in online courses, and parts of the curriculum are hands-on, whether it is programming or configuration and setting up, building up the IoT solution. You can also find us in telecom operators. So we are partners to Orange Egypt. We are also partners to Vodafone Egypt, where they utilize our Master of Things IoT platform. They have it in their own cloud, on their private cloud inside their data centers, and they sell IoT solutions based on Master of Things for their corporate customers usually. So how do we see IoT in brief? We see it as three main layers. One layer is the devices itself. The second layer is the connectivity. This is where telecom operators and connectivity providers, whether it be terrestrial or non-terrestrial, satellites or ground. The third layer is the application layer, and this is divided into two big layers inside. One is a common layer called the application enablement platform. That is responsible for collecting the data from all the devices, storing it, authenticating the devices for sure, and then authenticating the end users, providing a layer for application developers to be able to quickly build their applications. And then the last layer on top, which is part of the third layer, is the application towards the end users. These are usually web and mobile applications. So now let me go to the mission that we are proposing. We're proposing two missions to work with UNISEC here. One mission is to develop an emergency communication type of device. This device is actually an accessory to the phone. So if you are in a location somewhere on the earth where you don't have a mobile network coverage, wouldn't you have where you don't have terrestrial networks to work or ground network, then you can use this complementary device, which will communicate with your phone, take text from your phone. Think of it as your WhatsApp in remote areas. So where you don't have a network at all. So you type a message here, this will be transmitted through this emergency communication device. And this emergency communication device will transmit the data through satellites. The pictures we see here are imaginary pictures for sure. These are generated by Meta AI. So you will see three versions of how this device looks like. Uh, when this device is important and useful for, what is it good for? It is good for those who don't have access to the network. These are usually tourism activities. For example, in Egypt, it's a big country. We have a lot of areas that's not populated. It's meant for safari tourism. Usually they go outside the coverage of the grid, whether on a mountain like St. Catherine Mountain, for example, or they go for a desert trip for 5 to 6 days. And in these areas, they don't have uh, coverage from any ground network. Usually they used to rely on satellite communication on a satellite phones with a special setup. Sometimes they have only one phone that is serving a big group. Sometimes they don't have this at all. So with this emergency communication device, it can be used for transmitting short messages, uh, like telling your family that you're safe and sound and in a nice place you're enjoying, or you're asking for emergency help if something went wrong with you. Device is also useful for engineers and technicians who are working in remote areas for maintenance, like solar power station maintenance. These solar stations usually, some of them are used in remote areas where you don't have electricity connectivity. That also means you don't have a network, mobile network coverage as well. So this will be a good tool for them to report the status to their companies or their customers and inform the situation about the solar station. And other, not just solar stations, but oil pipes, and anywhere there is a need for a technician to repair something remotely. This is also useful for emergency rescue missions where there is natural disasters that can cause the standard ground telecommunication services to be not working. So this alternative solution will be a good fit. So that is one mission. And for this to work, we need to take care of the wireless communication, which frequency range that will be used, because we know from our experience in IoT, delivering IoT solutions in different parts of the world, that this is how the world map looks like. This is how the frequency ranges available for ISM, or industrial, scientific, and medical. Sometimes they call it the unlicensed range. So these are the frequency ranges used in different parts of the world. It's not the same everywhere, but at least we have six big regions where we have six frequency ranges that we can use. So it's not just the satellite that needs to take care of the frequency, but it's also the devices on the ground that are sending data. They need to comply with the frequency range used in their region. So for example, in Europe and parts of Africa, including North Africa and some parts of South and Mid Africa as well, we have this 868 megahertz frequency. So if you're in this region, you need to transmit the data using this frequency. But if you are in another region like Americas, you need to comply with another frequency. So whether you are in the satellite as the receiver part of the transceiver, you need to listen to this on top of US, but you need to listen to that on top of Europe. If you are developing a device that should be used by everyone anywhere, then we also need to take care of where are we now to start transmitting the data using the frequency allowed during within this region. That is the first part of the mission. So the second mission we are hoping to involve with UNISEC is to become the IoT application enablement platform for all the data collected from all the devices through all the satellite constellations from the UNISEC nano satellites through all the ground station. Where would be the destination for these data collected from all these devices? It needs to end somewhere on the cloud for the end users who own the devices to start looking at the data and start visualizing the data and start using it in their applications as well. This is where our Master of Things IoT application enablement platform becomes useful and mandatory. So this would be a cloud-based version that collects all the data from all the ground station, which originally came from various satellites and originally generated on the devices on the ground. So any device maker will log into our cloud platform and get his data. You can also start building visual applications, visualization of the data, charts, maps, dashboards, whatever it is, or data input output from end users on a web and on a mobile. That's what we are very good at in doing.
Okay, Basim, can you please wrap up in 1 minute?
That's all what I have. So I already finished, and you can find more information about our company in these two links. So I'm open to questions if you have. If I have still a few minutes for the questions.
Okay, thank you, Basim, for the idea